Okay, in this chunk of material from chapter 2, one way to connect it in your mind is to think about what we're trying to do is make new functions from old ones. Okay, so there's kind of three things that we're going to do to create these new functions. One of them is called piecewise functions, and what happens there is we take not the entire function, but we use two different functions and we cut off pieces of them and we put them together to make this one function. So for instance, here I have a function f that's composed of two different rules. This is like the y over here. So y equals x squared minus 4 or y equals x plus 2. And which rule you use depends on what your x value is. Okay, so we're going to look at an example of that in a second. I'm going to go through this for each of them. All right, now with arithmetic combinations and with composition, arithmetic combinations deal with when you might add, subtract, multiply, or divide two functions in order to come up with a new one. Okay, and those operations are the same operations you do with numbers. It's just we're going to use them with functions, not just numbers. Okay. And then composition is one, usually if you came through like 98 and 100, you've never seen this operation. It looks like a degree sign, but it's going to be on the same line kind of where you would have put a plus sign. It's a little open circle, and it means composition of functions, which is very different. We're going to look in depth at that. Just doing a quick overview of what this next chunk of material is so that as you learn it, you have a way of making sense of it, okay? And so with arithmetic combinations, I'm going to do the example of, well, what if I created a new function by taking f and subtracting g? And then with composition, I'm going to look at what does it mean if I say the composition of f with g? How do we do that? What is that equal to? Okay, so let's look at each of these examples. So this will be my first example, this will be my second example, and this will be my third. Okay, so we're going to look at piecewise here. Okay. And so what happens on this one is I'm being asked to think about what this means. So I'm going to do a few example problems related to this. Okay, so if you were given that rule right there, okay, one of the things you might do is just be asked to evaluate the function. So you might be asked to find f of like f of 3, okay, or maybe f of 2, or maybe f of 1, or f of 0, or even an f of a negative 2. Could be fractional. I'm just choosing not to do that, okay? All right, so if we looked at these, what you would have to do is determine which of the two rules should you use if your x is 3. So you have to think about whether 3 is less than 1 or bigger than 1. Since 3 is bigger than 1, then that means I'm going to use the rule x plus 2. So that means in place of the x, I'm going to be putting 3, and this function just says I would add 2 to it, and so my overall answer would be 5. Okay. I would do the same thing for f of 2. It's just the x value is now 2. The function says I need to add 2 to that, so my output would be 4. So f of 2 would be 4. Now, f of 1 is a little bit tricky, okay, because 1 is right on that boundary between the two. So you have to understand that this one is the one that allows you to be equal to 1. So you're going to put a 1 in for the x on the bottom rule. You can't use the top rule. So you're going to put a 1 in for x on the bottom rule, just like you did on the others. You're going to add 2, and that's going to give you 3. Now, when we get to f of 0, the x of 0, that's less than 1. So that means I have to use the top rule. So that means I'm going to do the 0 here. Then I'm going to square it and subtract 4. So I'm going to get a negative 4 on that. Okay, so these values in here, you know, are x's. What you do with the piecewise function is these are the conditions, okay? Consider these first to know what rule to use. You can only have one answer to these questions. It's a function. It's just you have to decide which one applies. So if the x is -2, since it's less than 1, I'm going to use the top rule for that. Okay. So that means right here in place of the x, I'm going to put -2, but then I'm going to square it and subtract 4. And so I'm going to wind up getting 4 minus 4, which equals 0. Okay. All right, so we've gotten some data there. I thought it would be something that might help you understand a piecewise function just to look at a graph of those, of what they look like. Okay, so let's suppose we were trying to graph the piecewise function. Most of the time, I just ask you to do this with a multiple choice option. Okay. All right, so you've already gotten some data that's going to help you. So when you're thinking about trying to graph this, okay, what I like to do is see what's going to happen in the various areas of the coordinate plane. And I consider those conditions right there, how one thing happens when I'm less than 1, one thing happens when I'm bigger than 1. Okay, so let me put some tick marks on here. Okay, so if I'm less than 1, well, here's where 1 is. This is not an asymptote. It's not a feature of the graph. It's me in my mind separating the coordinate plane into the area where x is bigger than 1 and the area where x is less than 1, okay? And when I'm over here on the area that's where the x's are all bigger than 1, when you're bigger than 1, you're supposed to use the rule y equals x plus 2. When you're over here, x is less than 1, you're supposed to use the rule y equals x squared minus 4, okay? So we've already collected some data. So we just need to think about what the graphs are going to look like, okay? And so for instance, I'm going to draw it down here. When we did this one, we know we use it when we're to the left of 1. I still would like to know, though, what happens at the boundary. So the two I found that fall in that range would be an x of 0, and we calculated that and found it goes with -4. And when x was -2, we worked that out and found out your y would be 0. I also like to know what happens at 1, even though I'm not allowed to use that rule, because I have to show my graph going all the way to that boundary. Okay, so I need to know where it would have hit that boundary. So when I put in a 1, I would get 1 squared minus 4, and that would be -3. Okay, also you should already know when you see that x squared that that should be a parabola. And when you see this one being just y equals x plus 2, that should be a line. Okay, you should have that in the back of your mind. So you don't need to find a ton of ordered pairs. So here's 0, -4. Here's -2, 0. Okay, 1 would have been at -3. And if I did a -1, it would also be at -3. This is a parabola, and we're just seeing now where the parabola would have been. It would have been right here. It would have come in, hit that low spot at -4, turned around, and come back up. The thing is, I'm only supposed to use it when I'm to the left of 1. So that means this is really the only portion of it that I'm going to use right here. I'm trying to make that thicker. Okay, trying to bold that side of it. That's the side of it I'm going to use. I'm not using that part over to the right. And when I'm right there at the boundary, okay, when I plugged in the 1 and got the -3, what I need to do there, I need to clean this up a little bit right there. Let me make that less pronounced. I need to make an open circle happen when I'm right here. Okay, trying to get that connected properly. Okay, when I'm right here at 1, -3, I'm going to use an open circle to indicate that there is not an or equal to on that. So I'm not supposed to use that graph when I'm there. Okay. All right, and then when we look at the y equals x plus 2, we've got some data we used for that. You know, when we plugged in a 3, we got 5. When we plugged in a 2, we got 4. When we plugged in a 1, we got 3. Okay? Whatever we plugged in, we just added 2. So let's go ahead and plot those. So here's 3, 5. Here's 2, 4. And then 3, 1, 3 would be here. So that would be the line that kind of looks like this. But I only use it when I'm to the right of 1. So that's the only section that I'm going to make solid. Okay, when I'm right there at the boundary, there is an or equal to on that one. So I'm going to make a filled in dot to tell people that I'm using it when I'm right there on the boundary. So there you have the graph of the piecewise function to think about. You see how we had a parabola and a line, but we just cut it into pieces, and we used one piece when we were to the left of 1 and a different piece when we were to the right of 1. But all together, that is our function, okay? All right, and so another thing you might be asked to do is to determine the domain and range of that function, okay? So I want to try to squeeze that in on this page right here. I'm going to write it right here. So domain, you know by now, are our x's. So that's the x's of these points right here. This is just a whole bunch of points, the x's of those. So if you think about smashing your function to the x-axis so that you figure out what the x-coordinate is for every point, okay, so think about where the x-coordinates would be for all of these points, but not just for this piece, also for this piece. Can you see how we would have stuff covered up from way out here? And even at 1, we have a point up there with a filled in dot, so that an x of 1 also has a corresponding y value. So all the way, not stopping there, because this keeps going, doesn't it? So it's going to be all the way from negative infinity to positive infinity for the domain on that one, okay, with the way I have this set up, okay? All right, now let's think range. So for the range, try to get it to erase a little bit, clean up a little bit of an area here. Okay. So let me get rid of those vertical marks because now we're going to focus on range. I'm going to do it in a different color. We do it in blue. Okay. So for range, we should be thinking about the y's. So we should be thinking about the y coordinates of these points. And so like this point would have a y coordinate here. This point though would have a y coordinate there. It looks like there's a gap in the graph, but these points really fill in that gap. See how all of those would have y coordinates that we would obtain? So this is kind of an interesting one. So really, I don't have anything below -4, but from -4, it's going to go all the way up to here. This point would have here, but these would also have y coordinates over here, so it would just keep going. So the range would be from -4 all the way to positive infinity, including the -4. Now, depending on how you cut it and which one you have being applied in which area, you can have very different situations happen. I did this in class and I had my inequalities the other way around, and I got a different looking piecewise function with a different domain and range, okay? All right, so that's the domain and range of a piecewise function, and that's the piecewise function itself, okay? All right, now let's go ahead and do a quick overview of what happens when you have combinations and composition. I'm going to create 2 pages here, and we're going to do them on the 2 pages. Okay, so here I want to do the combination. Here I want to do the composition. Okay, so I'm going to do an arithmetic combination. And the example I chose to do was f minus g of x. And remember, f of x, that was our x squared minus 4, and g of x, that was our x plus 2. And that's going to be true on both of these. F of x was x squared minus 4, and g of x was x plus 2. Okay, so the combination one is pretty intuitive. I would hardly even have to say anything about this and you would get it right. When you're doing f minus g of x, it's defined to be f of x minus g of x. And so you literally just take the rule for the f function and take the rule for the g function and just apply that formula. What you got to watch out about, I did one of the harder ones, is that I was subtracting those, and the g function has two terms. So don't forget about things like distributing that -1. So this would be x squared minus 4 minus 1x minus 2. And then I would just combine my like terms to get it all simplified. And that would be the new rule that I created. Okay, that was my f minus g of x. And see, that's like a new function. I could call it something new like h. The h function is this rule, x squared minus x minus 6. Now we can do the same thing with adding, multiplying, and dividing. Same concept, and we'll do that. I'll do that in another video. This is kind of the big overview of the last chunk of material we have to cover from chapter 2, which is piecewise functions, arithmetic combinations, and composition. Okay? All right, now composition is something that should be kind of new to you, but I've really been harping on you making sense of function notation, because once I define what that is, then all you have to do is follow the instructions you're being given, right? Here's what it's defined to be, f of g of x. And that's just a use of function notation. So you just do what it says, okay? So g of x is x plus 2. So I can replace g of x with x plus 2. I just need to then do f of that. And I had you do a lot of that. Do f of x plus 2. And to do f of x plus 2, okay, what you needed to do was take that x plus 2 and come over here and plug in the x plus 2 everywhere you see the x. So f of x plus 2, okay, should equal the x plus 2 squared minus 4. Okay, so that's going to be worked out so that we can get it simplified. So that's going to be x squared plus 2x plus another 2x plus 4. That's just that part. And then I have to do the minus 4. And so when I combine my like terms, I just get x squared plus 4x. Okay. All right, so that wound up being right there. Let me erase this part and just continue my equal signs like that. So, you know, that wound up being what f composed with g of x would turn out to be, okay? All right, so we're going to look more at composition. We're going to look at how g composed with f would be a little different and talk about how to make sense of it and all of that. I'm going to do that in another video.